This DIY educational kit is an audio and visual alarm notification system that you can build yourself. When you make this kit, you will learn about important electronic components like capacitors, transistors, resistors, buzzers, LEDs, and electronic circuit concepts like flip-flops. To access the latest kit documentation, enter the kit ID in the search box. To get started, here is the overview of the kit. Here you can find the related videos. These are the tools you need to build this kit. This is the inventory of the kit, including PCB, capacitors, resistors, a buzzer, transistors, and LEDs. This is the PCB of the kit, and this is the circuit schematic of the kit. If you are interested in diving deeper into the design, please visit our website for classes and workshops. This kit uses 3 types of resistors. You may have received either 4-band or 5-band resistors in your kit. Here is the 4-band color coding for 680 ohm resistor. Here is 5-band color coding for 680 ohm resistor. Here is the 4-band color coding for 10 kilo ohm resistor. Here is 5-band color coding for 10 kilo ohm resistor. Here is the 4-band color coding for 1 kilo ohm resistor. Here is 5-band color coding for 1 kilo ohm resistor. These are the spots where the resistors should be placed. Use the color coding and the resistors ID to place them correctly. These are the spots where the 680 ohm resistors should be placed. These are the spots where the 10 kilo ohm resistors should be placed. These are the spots where the 1 kilo ohm resistors should be placed. Mount the components in place, bend the leads at the back, solder them, and cut the excess leads. In this section, we solder the LEDs to the PCB. This kit uses 4 LEDs. They should be placed in the position shown on the PCB. Make sure the positive and the negative legs are oriented correctly. The way to identify the LED polarity is the longer leg is positive and the shorter leg is negative. Some LEDs have a flat edge on the negative side. The most reliable way is to look inside the LED casing. The shorter connector is positive and the longer connector with the bend is negative. Insert the component in place, bend the leads at the back, solder them, and trim the excess leads. Look inside the LED casing. The shorter connector is positive and the longer connector with the bend is negative. This kit uses two electrolytic capacitors to be placed in position C1 and C2. Electrolytic capacitors are polarized components, so correct orientation is important. The way to identify the polarity of capacitor's legs is the longer leg is positive and the shorter is negative, and there is a white band on the capacitor's body pointing to the negative leg. Place the capacitors in the correct positions, ensure the polarity matches the PCB marking, mount the components in place, bend the leads at the back, solder them, and cut the excess leads. This kit uses 3 NPN transistors to be placed in Q1, Q2, Q3 spots. Place them in the marked positions on the PCB. Make sure the flat side of the transistors matches the flat side printed on the PCB. This ensures the 3 legs of the transistor, base, collector, and emitter, placed into the correct holes. Mount the components in place, bend the leads at the back, solder them, and trim the excess leads. This kit uses one active buzzer. It should be placed in buzzer 1 position. This buzzer is polarized. The way to identify the negative and the positive leg is the positive leg is marked with a plus on the casing of the buzzer, and sometimes the positive leg is longer. Align the positive leg with the plus marking on the PCB. The sticker on the buzzer indicates the voltage of the buzzer. For example, a 12-volt buzzer, a sticker text is black. You can put the sticker on the PCB for your future reference. Mount the components in place, bend the leads at the back, solder them, and cut the excess leads. In this section, we connect the power connector to the PCB, which is a 9-volt battery connector. The red wire should be connected to the positive, and the black wire should be connected to the negative. To test the kit, you need a 9-volt battery. It could be a disposable or a rechargeable battery. Connect the battery, the LEDs should start flashing, and the buzzer should start beeping. Now the assembly of the kit is complete.